Casting in OOP refers to converting a variable from one type to another. This variable could be the reference object in Java. There are two types of casting. One is implicit, which is automatic, like this one. Another one is explicit, which is manual. When dealing with objects and class hierarchies, like in inheritance, understanding implicit and explicit casting is crucial for understanding OOP. Take, for example, the static method m that takes in an object. Since student is an object in the OOP paradigm, this new student or the newly created instance is actually an object, is a. So O, whereas it is pointing to the memory location of this new student object, it is of type object, which is the superclass of student. This object O equals new student is also known as the implicit casting, which is legal because student is an object. So there is, in a sense, an automatic conversion of student into an object at runtime. This renders M, which takes in object X, a valid operation when it is invoked with a new student object as its argument. This implicit casting is safe because the subclass or student is guaranteed to have all of the features of the superclass object. So if you look at the UML again, where object is the superclass and student is a subclass, what we're doing with implicit casting is we're actually converting student to object in a mechanism called upcasting. Upcasting is a whitening effect. Why is that? What does that mean? It means it is moving from a more specific type for the student subclass to a more general type object, the superclass. Let's look at why casting is necessary. Let's look at the situations where we have student B equals O, and this O is our object. This operation is not good, introducing a compilation error. The reason is because an object is not necessarily an instance of student, whereas the other way around is valid. Object O equals new student. Student is an object. Remember the is a relationship, which is inheritance in OOP that we talked about earlier. Going back to our UML, where we have object as our superclass, your student extends object, or student is a subclass of your object. The only way for student B equals O to be valid is you will enable what's called explicit casting. This explicit casting involves manual casting of O into student. In essence, manual casting or explicit casting goes from top to bottom in a process called downcasting. Downcasting is manual. It is not that safe as upcasting because not all of the objects is a student. It is not safe because if object is not a student in your code, in your design, we're going to have an issue. This type of explicit casting is very similar to the type of casting that we see in primitive data types, where you will cast an object to its intended destination type inside a pair of parentheses. The issue with this, as we stated earlier, if object is not a student, you end up getting what's called class cast exception, which is an error if the object being cast is not actually an instance of the subclass. As opposed to upcasting, downcasting is a narrowing effect. Namely, it is moving from a more general object superclass to a more specific student or subclass. Understanding when and how to use implicit and explicit casting ensures that you handle objects correctly in OOP, especially in the area of inheritance, leveraging polymorphism and dynamic binding. Let's look at an example of downcasting. Casting from superclass to subclass is downcasting, which requires explicit casting. For example, fruit being a generic class or superclass is instance fruit. Lowercase f is a superclass of either apples or oranges. In an UML representations like this, you would invoke explicit casting to make fruit into a apple instance and orange instance, respectively, in these two examples. This type of casting may not always succeed because you don't know what your general class, whether it is of apple type or orange type, because anything can happen dynamically. So whenever you invoke explicit casting, you have to make sure that operation is what you intend to do. How do we safeguard this? Well, it turns out there is an instance of method in object. Let's take a look. In this example, you can make use of the instance of operator to test whether an object is an instance of a class or not. Let's say, for example, you have this dynamic object. There's dynamic binding involved because now that we have this my object pointing to a circle, which means circle is a object in an inheritance sense. Before doing anything with your my object, we can use the instance of method to double check whether this my object is of the circle type. If so, then print this out. Then you can safely and manually or explicitly cast my object to a circle object and get its diameter. Always remember the is a relationship. Whenever you do the casting, checking to see if the object that you're trying to cast into fits the is a test. Namely, is fruit an apple or is fruit an orange? Probably not. However, the other way around is correct. Namely, apple is a fruit or orange is a type of fruit. As long as you have this level of understanding and your design matches this level of understanding, it should be fine.